All right, everybody, good evening. So, first of all, today we are going to. Okay, before that, just let me know if my voice and my video is audible to you. Please. Well, I think I'm audible to almost everybody. Somebody mark my voice is not audible. Please do check your device once again. All right. So today we are going to start with application of derivative. This chapter will go for 3 or 4 days. Like today we are going to discuss about the rate measure and tangent and normal. Tangent and normal has been rejected from the syllabus of CBSE, but yes, it is still in the syllabus of JEE Mains as well as JEE Advanced. JEE Mains maybe it is not too much dominant, but yes, it is in there in the syllabus of JEE Advanced. Also in your state entrance exams. The next lecture may we will cover with the monotonicity and we'll also discuss about the maximum minima. And in the next lecture, we will do questions on monotonicity, maximum minimum. All right. So now I'm going to start with rate measure. So rate measure is nothing but the change in the rate. Got it? It's simply dy by dx. That is change in y creating small change in x. So input change in y is creating small change in x. So what we have to do, we just have to differentiate a relation in x and y which is given to us and find the rate of change. All right. See, the best way of learning it is through the example only. Now the example is how fast the area of a circle increase when its radius is 5. Got it? Now they're asking for with respect to diameter, and with respect to radius. All right. Now see, area is pi r square. Got it? Area is pi r square. They are asking for with respect to radius, rate of change of area with respect to radius. Well, we will just differentiate it with respect to r. So dA upon dr is 2 pi r. Got it? So rate of change of area with respect to radius when radius is 5 is going to be what? 2 pi into 5, that is 10 pi. All right. Now they're asking for rate of change of area with respect to diameter. So this area, which is pi r square, can also be written as it is pi by 4 d square. I assume d is the diameter. Got it? So radius is half of diameter. I replaced r by d by 2. Now, rate of change of area with respect to diameter is what? Pi by 2 into 2d. So dA by diameter change with respect to this is pi d. Now this is what? D is 2r. So it is again 2 pi r. So rate of change of area with respect to diameter is while radius is 5. So it is also going to be 10 pi. Am I correct? Got it? Now see, sometimes if they ask you, the given is that radius is changing at a rate of 2 centimeter per minute. Now they are asking you to find rate of change of area with respect to rate of change of area with respect to time when radius is 5. So now what we will do, area is pi r square. Now you differentiate it with respect to t. So dA by dt is what? 2 pi r dr by dt. Got it? So dA by dt when radius is 5 is 2 pi into 5 and dr by dt is given to you as 2 centimeter per minute. Got it? So what will be the final answer? It's 20 pi centimeter square per minute. So this is the rate of change of area with respect to time. Got it, everybody? And this must be easy for you if you have done application of derivatives in your classes. Take a breath, absorb it. Even in JEE mains, they also ask these kind of questions only. Now, let's move to the next example. The volume of a cube is increasing at a rate of 9 centimeter cube per second. That means rate of change of volume is 9 centimeter cube per second. How fast is the surface area increasing when the length of the edge is 10 centimeter? Okay, anybody who would like to solve it, I give you a couple of minutes. Just get the answer and like send it in the chat box quickly. Twenty-seven into 10 square. Okay, anybody else? 2700. Very good, not bad. Now, let's see. Volume of a cube is increasing. Now, see, volume of a cube is, say, x cube. Got it? So, dV by dt is 3x square dx upon dt. Now, surface area is 6x square. Surface area is 6x square because there are 6 faces of the cube. So, ds by dt is 12x dx upon dt. Am I correct? Now, rate of change of volume is given and rate of change of area, surface area they are asking. You just divide both of them. So, ds upon dt divided by dv by dt is equals to 12x upon 3x square. So, it comes 4 upon x. Now, ds by dt is 4 by x into dv by dt. Now, 4 by x will be what? 10 centimeter h into dv by dt is 9 centimeter cube per second. So, answer is 3.6 centimeter square per second. How are you guys getting answer as 2700? Bhuvan, can you unmute yourself? Bhuvan, and this Srujana? Okay. So, how fast is the surface area increasing when the length of the edge is 10 centimeter? Is everyone clear about it? So this was a decent question. Now, the length x of a rectangle is decreasing at 5 centimeter per minute and width y is increasing at 4 centimeter per minute. When x is 8, y is 6, find the rate of change of area of the rectangle. Okay, quickly do it. You got a couple of minutes to do this. Mark your answer in the chat box quickly. Yes, anybody? Two centimeters square. All right, anybody else? Now see, length x is decreasing at 5 centimeter per minute. Means dx by dt will be taken as -5 because it is decreasing. Now y is increasing, dy by dt is 4 centimeter per minute. Am I clear about it? Now area is what? Area of a rectangle is xy. So differentiate it with respect to t. Here in the right side, I will apply product rule. So it is x dy by dt plus y dx upon dt. Got it? Now put the values of x. X is 8, dy by dt is 4, minus plus y is 6 and dx by dt is -5. So it is 32 minus 30. It comes out to be 2 centimeters square per minute. This is the rate with which its area is changing. Got it? Is it fine? Now, okay, we'll write on another question. The question is something like this. A boy, 1.5 meter tall, is walking away from a lamppost situated at a height of 6 meters. Got it? If speed of boy is 5 meter per second, find the speed at which his shadow is lengthening. His shadow is lengthening. Take a minute. This is a very good question. Tell me what to do. Yes, 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 quickly. Now see, there is a lamp post. Its height is 6 meters. Now there is a boy like this. Height of the boy is 1.5 meter. So if it is the lamp post here, light will go over his head and will be like this. So that means this is going to be the length of the shadow. I assume it is y and it is x. Now, information given to me is that the boy is walking away from the lamp post. Written walking away from a lamp post at a speed of 5 meter per second. That means dx by dt is increasing at a rate of 5 meter per second. Am I correct? Now, let us assume this angle is theta. So tan theta is, in the small triangle, it is 1.5 upon y. In the large triangle, it is 6 upon y. 6 upon x plus y. Am I correct? Now, cross multiply. If 1.56 will go 4 times. So x plus y is equals to 3y. Sorry. X plus y equals to 2y. 4y. So x is equals to 3y. Or I should say y equals to x by 3. So dy by dt is 1 by 3 into dx by dt. Now, value of dx by dt is what? 5 centimeter per second. So from there, dy by dt is 5 by 3 centimeter per second. Got it? Again, a very important question with a JEE point of view. Now, try this question. A water tank has a shape of inverted right circular cone whose semi-vertical angle is tan inverse 1 by 2. Water is poured into it at a constant rate of 5 cubic centimeter per minute. Then the rate at which the level of water is rising at an instant when the depth of the water in the tank is 10 centimeters. Yes. Think about it, make a diagram. Now see, that much of time is enough. There is a water tank in the shape of inverted right circular pool like this. This is it. Got it? So a water tank has a shape of inverted right circular cone. Semi-vertical angle is this. So if this angle is theta, that means tan theta is 1 by 2. Water is poured into it. Water is being getting inside at a constant rate of 5 centimeter cube per minute. That means volume of the water is increasing. dV by dt is 5 centimeter cube per minute. Am I correct? Per hour. Per minute is given, fine. Then the rate at which the level of water is rising at an instant when the depth of the water in the tank is 10. Now see, let us assume after some time this is the depth of water. Means there is water below this point. Got it? If I assume radius of the cone is r, height of the cone is h. That means tan theta is r upon h. Tan theta is 1 by 2. So that means h will come to r. Because this is 1 by 2. Now, volume is what? Volume of the cone is 1 by 3 pi r square h. I will replace r in terms of h. So volume will be 1 by 3 pi h by 2 whole square into h. That is 1 by 12 pi h cube. Got it? Now differentiate it with respect to time. So dV by dt is 1 by 12 into pi into 3h square dh upon dt. So dV by dt is what? 4 pi h square dh by dt. 1 by 4, sorry, not 4, 1 by 4. Am I clear? Now, that means dV by dt is 5 into 4 upon pi h square is dh by dt. Now they are saying then the rate at which the water is rising at the instant when the depth of the water in the tank is 10 meter. Got it? So depth of the water is what? 10 meter. That means replace h as 10. So your dh by dt is 5 into 4 upon pi and h is what? 10 into 10. Got it? So it will go 2 times. So 1 upon 5 pi. Got it? So dh by dt will be what? 1 upon 5 into 22 by 7. So it is 7 upon 110 centimeter per minute. Got it? Take a moment. All right. Now, let's come to tangent and normal. See, Let y equals to fx be a function with graph as shown in the figure. Alright. Consider the secant PQ. If Q tends to P along the curve passing through points Q1, Q2, Q3 and so on. So what they are saying, I'll make another diagram for you. Say this is a curve. Now they are saying PQ is a chord of this curve. Now as P approaching towards Q, as P approaching towards Q, so there will be a movement while P and Q will be very close to each other. All right. So when P and Q will be very close to each other, it will become a tangent. Like this. It will become a tangent. So that is what they are saying. Ki if Q approaches to P, Q approaches to P or P approaches to Q, the secant PQ will become tangent at P. So if P approaches to Q, tangent will be at Q. Tangent at Q. And if Q approaches to P, it will be tangent at P. Got it? Now what is the equation? See, this is the same thing I have also explained you in application of derivatives. Okay, slope of tangent is f dash x, that comes dy by dx. Why so? Say this is the curve. There is a point x comma fx. Then there is a point, say this is p, this is q. This is x plus h, f of x plus h. This is a chord. Now as q approaches to p, this is q. Now this is what? F of x plus h minus fx, and this base is going to be h. So as q approaches to p, slope of tangent theta, slope of secant theta, tan theta will be fx plus h minus fx upon h. This is what they are saying, slope of chord PQ. Got it? So, and if Q approaches to P, it will be slope of tangent at P. Slope of tangent at P. And that will be what? Limit h approaches to 0, f of x plus h minus fx upon h. And the same quantity is what we call dy by dx or f dash x. So dy by dx gives you the slope of the tangent. Dy by dx gives you the slope of the tangent. Now, sometimes what may happen, a line may be a tangent to the curve and also crossing it. Like this is the example of y equals to x cube. Even the same thing happens with y equals to x to the power 1 by 3. In that case, the graph will be something like this. Here it is also the case that tangent is crossing the curve. Tangent is y-axis in this case. And here tangent is what? X-axis. Got it? Now, the value of the derivative at px1 y1 gives you the slope of tangent. Symbolically, f dash x1 or dy by dx at x1 y1. This is what we call slope of tangent at the point x equals to x1. And then in that case, equation of tangent is what? Y minus y1 is slope. This is what? Slope into x minus x. So equation of tangent will be y minus y1 is equals to slope into x minus x1. Equation of normal is y minus y1 is minus 1 upon dy by dx into x minus x. Got it? Y minus y1 is minus 1 upon dy by dx into x minus x1. So ये tangent and these are the tangented normals. Got it? Now see the simple example. Find the equation of tangent to this curve y equals to x cube minus 1 x minus 2 at the points where curve cuts the x-axis. Okay, take a moment. First of all, find the points where this curve is crossing the x-axis. Tell me quickly. Find the points where this curve is intersecting the x-axis. What will happen when the curve cuts the x-axis? When the curve cuts the x-axis, in that case, dy by, sorry, in that case, y equals to 0. So what you will do, x cube minus 1 into x minus 2 equals to 0. This x cube minus 1 is x minus 1, x square plus x plus 1 into x minus 2 equals to 0. Now this factor has no real root. That means x equals to 1 and 2. So these are the 2 points where this curve intersects the or cuts the x-axis. Now find dy by dx. Is first derivative of second one plus second derivative of first is 3x squared. Got it? So what is dy by dx at x equals to 1? It is going to be 1 minus 2 into 3. That is minus 3. Now, what is dy by dx at x equals to 2? It is 7 plus 0. So slope of tangent at x equals to 1 is minus 3 and slope of tangent at x equals to 2 is 7. Now, equation of tangent at 1 comma 0 is what? 1 comma 0 is what? Y minus 0 is slope. Slope comes minus 3 into x minus 2. Got it? So it became 3x plus y equals to 3. Similarly, equation of tangent at 2 comma 0 is y minus 0 is in this case slope is 7 into x minus 1. So this implies y equals to 7x minus 7. So this is how we find the equation of tangent to a curve. Am I correct? Now let's go with another question. The equation of normal to this curve x plus y is x raised to the power y, where it cuts the x-axis. Quickly do. You got 2 minutes with you. Quickly get the answer and send me in the chat box. Yes. If not the question, at least tell me the slope of the normal or tangent. Quickly. Slope is 1. Somebody answered. Bhagat. Hey Bhagat, how are you? Bhagat, can you unmute yourself and talk to me?
Thanks.
Bhagat, how did you get this? How to approach? Bhagat, it will be great if you can speak up.
By doing log on both sides and differentiating,
Sorry,
by adding log on both sides and differentiating it,
log at both sides. And how did you took log in the left side? Bhagat,
sir,
yes. How did you take log on left side?
log of x plus y is equal to
Sorry,
log of x plus y is equal to
okay.
1 by 1 upon x plus y of 1
Very
plus
good,
d
very
multiplied.
good. This is what I wanted to hear, because what most of the students do a mistake, they take a log and then they write it, this is equals to log x plus log y. It was great that you have not done this. See, equation of normal where it cuts the x-axis. So whenever you cut the x-axis, what will happen? Y goes 0. If you place the value of y as 0, you will get x as 1. Got it? So the point is 1 comma 0. Now, if you want to differentiate, we can also write it like x plus y is e to the power y ln x. This is a very simple property of log, that a to the power x can always be written as e to the power x ln a. Got it? Now you can differentiate 1 plus dy by dx is e to the power y ln x into derivative of this, that is y upon x plus ln x into y ka derivative dy by dx. Got it? Now in this entire equation, put x equals to 0, sorry, put x equals to 1 and y equals to 0. So 1 plus dy by dx is, it will become e to the power 0, which is 1, 0 plus ln 1 also getting 0. So dy by dx plus 1 is 0. Then it is dy by dx is minus 1. Got it? So this is the slope of tangent. So slope of normal will be what? Plus 1. Now equation of normal will be y minus y1, which is 0, is slope 1 into x minus 1. So y equals to x minus 1 is your answer. Am I clear, everybody? Got it? Is this fine? भगत यही किया आपने? Bhagat, did you do the same thing? Very good. Anybody else who did the same thing? Reply in chat box quickly. Anybody else? Well, now, the equation of normal to this curve y equals to x sin x cos x at x equals to pi by 2. Find the equation of normal to this curve at x equals to pi by 2. Quickly do. You got 1 minute with you. I want correct answer now from maximum of you. Yes, anybody? See, equation of normal, what will be dy by dx? Dy by dx is 1 plus, this is first function derivative of second minus cos x minus sin x plus cos x, derivative of first is also cos x. So it is 1 plus cos square x minus sin square x. So it is 1 plus cos 2x. Am I correct? So dy by dx at x equals to pi by 2 is 1 plus cos pi. Cos pi comes minus 1. So it is 1 minus 1, that is 0. That means at x equals to pi by 2, slope of tangent is 0. That means slope of normal is going infinite. That means normal is what? Normal is parallel to y-axis. Got it? Now, while x equals to pi by 2, y is also pi by 2. This is the point on the curve pi by 2 comma pi by 2. Now, equation of this line, which is parallel to y-axis, is what? Y equals to pi by 2. Sorry, x equals to pi by 2. This is the equation of normal at this point. Got it? This is a simple question, undoubtedly. Now, given a point P, A, comma B, this is what tangent from an external point. Now, sometimes if you are required to find the tangent from an external point, so what do? Given a point P, A, comma B, which does not lie on the curve y equals to fx, like this is here. Then the equation of possible tangent to the curve y equals to fx passing through A and B can be found by solving the point of contact Q. Got it? So how do we do it? Let us assume that this point is, h comma f of h. So what is the equation of tangent? Y minus y1, that is fh, is equals to slope of tangent, that is f dash h, into x minus h. Yes or no? And now make this line pass through A comma B. Pass through A comma B. So yb minus fh is equals to f dash h into A minus h. Now A and B given to you, equation of the curve is given to you. So with this equation, you will get a simple equation in H. Solve that equation, get the point of contact. There can be more than one point of contact. Like this is highly probable that from this point, we are getting two tangents. Got it? Like take a simple example. find the value of C such that line joining this and this become tangent to this curve. Say this is the curve. On this curve, there is a point, say T comma C upon T plus 1. Now tangent at this point is passing through 2 points, that is 0 comma 3 and 5 comma minus 2. Am I correct? Now differentiate. Dy by dx is going to be minus C upon x plus 1 whole square. So dy by dx at x equals to t will be minus C upon t plus 1 whole square, correct? Now the slope of tangent is also the slope of line joining 0 comma 3 and 5 comma minus 2. So y2 minus y1, that is 5 upon x2 minus x1, that is minus 5. Correct? So from this you get t plus 1 whole square as C, and t you will get. Got it? You get t, you get the point on that curve. All right. Find the value of C, line joining this and this becomes tangent to this curve. Dy by dx is at t comma this. All right. Just a moment. Slope of the line will be C upon t plus 1 minus 3 upon t. And this is also minus 1. So from this, C upon t plus 1 minus 3 is minus t. So C upon t plus 1 is 3 minus t. Got it? So C equals to 3 minus t into t plus 1. Now we will solve these two equations and we'll get the value of C. All right. Well, this is all for the day. This is a very interesting chapter and highly scoring in every competitive exam. Got it? Just a small feedback from your end. Quickly.